Asphalt paving equipment works together to place a smooth asphalt surface capable of withstanding repeated loads from traffic. The process begins with a sweeper to remove dust and loose stones from the existing pavement surface. A clean surface ensures proper bonding between the new asphalt and the base layer. An asphalt distributor truck sprays a sticky asphalt adhesive to bond the existing surface with the new asphalt layer. Here, a tack coat is applied to prevent slippage between two asphalt layers. Spray nozzles are evenly spaced across the length of the spray bar. The truck moves at constant speed to achieve a uniform application. Shortly behind the tack truck is the paver. Here, the asphalt mix is dumped into a receiver hopper either directly from a truck or from a material transfer machine. Push rollers mounted on the paver frame push against the rear wheels of the truck. As the paver pushes the truck along, the mix is dumped into the hopper by raising the truck box. Adding a material transfer machine between the truck and paver has the advantage of reblending the asphalt from the truck box and also storing extra material if there is a truck delay. Transfer machines also have the added advantage of avoiding truck contact with the paver and possibly producing a bump. Slat conveyors move the mix from the front receiving hopper to the rear. Then augers spool the mix across the width. A screed plate then strikes off the asphalt to create a smooth profile. The screed is very important in controlling the cross slope and thickness and also providing initial compaction. The screed plate is warmed by built-in diesel or electric heaters, and most screeds are hydraulically extended, allowing variable paving width without stopping the paver. Screed position is further controlled using grade sensors with a ski or slope. The ski references the adjoining lane while the shoe traces the surrounding mat. They act to stabilize screed position and ensure consistent profile. Consistent force against the screed from continuous mix delivery is critical to stabilize screed position. Reduced force on the screed may cause it to settle and create a bump. While the mix is hot, roller compactors densify the mat. Properly compacted pavements should have a minimum 92% in-place density, or in other words, about 8% air volume. Smooth steel drum compactors are most commonly used, but some jobs may use a rubber-tired compactor. Most operations have at least two rollers. The first is a breakdown roller that achieves initial compaction while the mat is hot, from about 300 down to 200 degrees. The drum is mechanically vibrated to provide impact force and compaction. Vibratory frequencies range from 2,000 to 4,000 vibrations per minute. A rule of thumb is 10 to 12 impacts per foot for proper compaction. The final roller is known as the finish or cold roller. The finish roller smooths the final pavement profile in a temperature range of 150 degrees down to 100 degrees. The rollers make several passes across all areas of the mat to achieve density and smoothness. Mat temperature significantly affects compaction. A rule of thumb for this is to compact the mix at the highest possible temperature. Thin and thick layers can also affect density, along with compactability of the mix. Water is used inside the steel drums to add ballast weight to the compactor. Water is also sprayed on the drum to prevent material from sticking. Production of the paving operation is measured in tons per hour. Continuous paving operations must balance truck deliveries with the paver's forward progress. The goal is to keep the paver moving and ensure a constant force on the screed to achieve a smooth pavement. One or two extra trucks should be scheduled to account for cycle time fluctuations and ensure continual mix supply. Paver production is controlled by the ability to uniformly screed the material. Changes in mix properties such as aggregate size or asphalt content may change laydown rates. Rollers then must work to compact the mat as efficiently as possible. 3, 5, or up to 9 passes across the mat may be necessary to achieve the proper density. A cooling mat affects compaction. Truck deliveries, base and air temperature, and blowing wind all contribute to temperature changes. Adjusting the vibratory frequency and amplitude alters the compactive effort of steel wheel rollers, and operators must continually share information during the day to adjust the operations as needed. Asphalt paving equipment is synchronized to lay down and compact a smooth asphalt surface. Many pieces of specialized equipment work together to build our airports, streets, and highways.